What's up, guys? It's here. It's time. May's coming around, 2019. It's about time for the May 2019 AP Calculus AB and AP Calculus BC AP exams. And I've been working hard on this video, making a PowerPoint, compiling the best information, the most critical information that you need to know for the AP exam. So it took a lot of effort, took a lot of work. It's going to be a long video, but here's the thing. I just want to give a quick shout out to you right there watching, because I know you, if you're watching this video and you're going to sit through the entire 45-minute video, then you clearly like my content and you want to see more, and you're clearly going to stick with me and you want to support my content. So thank you so much for sticking with me and supporting me in my channel. If this content really helps you, please subscribe so that this can get in the hands of people who need help with calculus and would like more calculus help and would like quick and efficient ways to learn calculus. The other people I want to shout out is I want to give a huge shout out to Sean Bird. He wrote up these awesome handouts called AP Calculus Stuff You Must Know Cold. These handouts are fantastic, and I really use these handouts in helping me make these, this video. So I'll leave a link in the description so you can get access to these documents. They're really, really helpful, and they're cheat sheets for everything you need to know. All the big theorems, all the big... So I added some stuff on my own, but I took a lot of stuff from this document. So links in the description if you want to see access to the document. Yeah. So without further ado, I'm going to stop wasting your time. I've already wasted about a minute and a half of your time, but forget about it. Let's get right into the video, guys. Let's go. Yo, what's up, guys? Welcome to another AP Calculus video. In today's video, I'm going to teach you everything you need to know for the AP exam. So every single vital AP Calculus AB and BC topic that you need to get that 5 on your AP Calculus exam. For those of you in AP Calculus BC, at the end of the video, I'm going to do all BC content. So you're not going to see any BC content until the very end of the video. That way the AB people don't have to watch the entire video. I'm also going very fast. This is not meant to reteach you the class. Rather, it's meant to allow you to see what you need to work on and what you really don't need to work on. It allows you to look at a topic and be like, yeah, I know what that is, or look at a topic and be like, no, that needs further review. So I'm going very fast. It might not be smart to take notes, but if you want to take notes, I don't blame you. But I also would say that if you don't feel like taking notes, this PowerPoint will also be, I'll leave a link to this PowerPoint in the description below so you can get access to this PowerPoint and take notes that way, or lack of taking notes. Or if you'd rather print it out and write on the PowerPoint, that's fine too. But anyway, without further ado, let's get right into the video. Alright, here we go. We're going to start out with some algebra concepts that you really got to know in order to nail calculus. I like how I press space and my thing doesn't work. Oh, here we go. Alright, first key concept that you should probably know from algebra is the point-slope form. Specifically, this form of point-slope form I think is really important. I'm going to pull out my laser pointer. I think it's really cool to do this with a laser pointer. I think that point-slope form is a really important tool, especially in this form, because it really makes it easy. You don't need to simplify on the AP test. So knowing this form allows you to, once you find the derivative, you can just plug it into this equation, so that helps. Completing the square, it's a method of integration. I would review completing the square if you don't know how to do it. Long division, if you don't know how to do long division with rational expressions, I would go review that from Algebra 2. Again, just check that out on Khan Academy. Pretty quick. If you're in AP Calculus BC, solving system of equations for integration with partial fractions, that might be worth something reviewing. But also your calculator can do that. So if you know how to use your calculator, you don't really need to know this super, super well. And then finally, your natural log and log properties. So I've listed them out here. I'm not going to go over them. Again, if these are confusing, just go back to Khan Academy and look these up. But these are some algebra skills that I think that you should have down pat. You should just be able to do these really easily in order to be in this class. So refresh on those so that you can nail the calculus concepts. Next up, I want to talk about useful pre-calc skills that you don't necessarily need to know, but will make your life so much easier. The first off are the values of trigonometric functions for common angles. Now, this is actually, despite me just saying it was optional, these are actually not optional. You've got to know these like the back of your hand on the AP exam, and you got to be able to do the inverse tricks. You got to be able to go the other way. So if I give you this inverse sine of root 2 over 2, you can go back and say that's pi over 4. Know these pat down. There's a multiple choice without calculator, and they'll still throw trig at you. So make sure you know that. These actually are optional. Your trig identities. So you don't have to know any trig identities because we're not testing pre-calc, we're testing calculus on the AP exam. But these are probably the most common Pythagorean identities, or sorry, the most common trigonometric identities that come up on the AP exam. So if you notice them, it just might make your life easier. So if you happen to know them, great, use them. It might make simplifying stuff a lot easier. If you don't know them, not the end of the world, you'll be fine. But it will make some simplifying easier. Let's jump into the calculus. We'll start with limits. Now, in terms of limit properties, I've got a video on what the limit properties are, and I recommend you check out that video. I'm not going to cover limit properties here. What I am going to cover is the definition of the derivative. Now, you should know the definition of the derivative. Now, you're probably thinking, why do I need to know this? Even though I can just take the derivative, I know all the shortcuts. Well, College Board is very good at asking questions like, evaluate this limit, and it'll give you a limit in this form, and you can choose to either go all out and evaluate the limit or realize, hey, that's just the definition of a derivative. I'll just find the derivative at that point, and that's what the limit's going to be. So make sure you know the definition of a derivative. I also thought we'll cover L'Hopital's rule here while we're at it. So if you got a limit that is type 0 over 0 or type infinity over infinity, it's indeterminate. You can then take the derivative of the numerator and the denominator and then evaluate the limit. And you can keep repeating that if it is continually indeterminate until you get an actual answer. Moving on, we're going to talk about basic derivatives. These derivatives should be memorized. You need to memorize these derivatives. Also, I'm going to go ahead and pull out my pen. The natural log, remember, if it's got if there's a random function, like say this is x minus 2 in there, you can also remember the derivative of the natural log function is also u prime over u. So whatever, you take the derivative of whatever's inside and then divide it by that inside. So there, that's that for you. That's another trick there. But these all, you really need to, again, you need to memorize these. These need to come out of the back of your hand, all of these. And if you can't do these, take flashcards and flip them out. But you guys have been doing derivatives all year. You should know these and have them at the back of your hand. These are some optional derivatives. Now, I can even tell you right now, I'm going to the AP Calculus exam, and I know very little of these. So you don't have to know these, but they might come up on the AP exam, and they might make your life easier. But they're probably not going to come up all that often, so you don't really have to know them. All right, let's go over some derivative rules. There's 3 derivative rules that we need to go over. The first of which is the chain rule. Remember, the way we do the chain rules, it's like an onion. You're peeling off the onion. I'm going to switch back to my laser pointer here. It's the derivative of the outside. So you take the derivative of the outside function. But remember, the inside remains unchanged. I'm even going to mark that over here. The inside remains unchanged. Remains unchanged. And then you multiply by the derivative of the inside. So that's how the chain rule works there. Product rule, you guys also know the product rule. First times the derivative of the second plus the second times the derivative of the first. And then finally the quotient rule, low d high minus high d low over the square of what's below, or over low squared, however you want to learn it. Make sure you know your derivative rules. Go back and watch my videos on derivative rules if those still confuse you. Moving on, there's one more. I didn't label what this is. Let me go ahead and do that really quickly. So this is the derivative of an inverse function. So if you're given a function and you want to find the derivative of its inverse, simply take 1 over the derivative of the original function. So you take the derivative of the original function, but everywhere that you see x, it's almost like a weird chain rule. So it's like, remember when you take the chain rule, it's like the derivative of the outside, but the inside remains unchanged. But then, so basically you do that. You do the derivative of the outside, leave the inside unchanged. So leave the inverse function on the inside, but then don't multiply by the derivative of the inverse. Because remember, that's what we're trying to find. We're trying to find the derivative of the inverse. I have a whole video on how I prove that, and I talk about and do an example problem on this, but no derivatives of inverse functions. Moving on, we're going to talk about analyzing graphs. So you should know about the increasing and decreasing test. A function is increasing if its first derivative is positive, and decreasing if its first derivative is negative. You should also know the concavity test. Oh, I really don't like this. Hold up just a quick second. Sorry, I meant to put the second derivative there, so just pretend that red little dot is like another comma. But remember, concave down if the second derivative is negative, concave up if the second derivative is positive. I clicked it. Oh, maybe I need to do this and then click. Okay, cool. Critical point. Critical points are where the relative maxes and mins occur, and critical points occur when the first derivative is equal to 0 or does not exist. Inflection points occur when the concavity changes, so that's when the second derivative is equal to 0 or does not exist. And then finally, you should know your first and second derivative tests. So the first derivative test says that if the first derivative is equal to 0 or doesn't exist, and the first derivative changes signs either from positive to negative or negative to positive at x equals some value c, then that value c is a relative max or min, and we can label exactly what they are. Positive slope to a negative slope, that would be a maximum. So this is a maximum. And a negative slope to a positive slope, that is a minimum. So first derivative test. You can also choose to use the second derivative test instead. So if the first derivative is 0 and the second derivative is positive, that's a relative minimum. If the first derivative is 0 or doesn't exist and the second derivative is negative, that's a maximum. And if the first derivative is 0 or doesn't exist and the second derivative is also 0, then it's inconclusive and you have to resort to the first derivative test. Know all of these tests and know how to find critical points and inflection points. I guarantee you this will come up on the free response section. There will be at least like 3 or 4 multiple choice questions on this, if not even more. This stuff is so important. Really get this stuff down. Let's moving on to related rates using the guess method. The guess method really saves my butt when I do related rates, so I recommend it to you guys. First off, I don't include this, but I always draw a diagram. But then what you're going to do is you're going to list out all the given information that you're given in the problem, identify the unknown rate that you're trying to find, set up an equation that relates all the given and unknown variables, then solve. Usually when you solve, you're going to differentiate. But remember, you're differentiating with respect to time, so it's implicit differentiation. And then you'll substitute in the given values so that you can find the answer. And then finally, you state your answer. Related rates problems. Go check out my videos on related rates. Next up, we've got optimization or applied max and min problems. I don't have a really great way of like a consistent way of doing these, but this is kind of like, I guess, kind of a general way that you could do this. Draw your diagram. Write an equation that specifically uses the value you want to maximize or minimize. So for example, if you're trying to maximize area, then maybe use an area equation. But make sure you only have one variable and use another equation maybe to substitute in only one variable. Differentiate. You shouldn't need to do implicit differentiation when doing this. Then just becomes a standard finding maxes and mins and stuff like that. So you're going to find critical points. You're going to use the first or second derivative test, whatever works for you and whatever you choose. Remember to check your endpoints because you're finding absolute maxes or mins, so make sure you check those endpoints, and then finally state your answer. Optimization problems. Let's move on to other applications of derivatives. So obviously, there's finding equations of tangent lines. So you find the slope by evaluating the derivative of the desired point, and then using point-slope form, like we talked about at the start of the video, use point-slope form to write the equation, and AP doesn't dock you for not simplifying on the free response, so I would encourage you, once you write that point-slope form, just box the answer and move on. Next up, linear approximations. So this is a linear approximation, and you'll notice if you look at this equation, this really is just, again, point-slope form. But the big idea about linear approximations is it can be used to approximate the value of a function around that value a. So for example, if you plug in 2, you'll be able to approximate what the value of that function is roughly around the 2 area. Moving on, let's move on to integrals real quick. We'll jump back to like motion problems once we move a little bit forward. We'll jump back to Riemann sums. I just kind of decided to jump around a little bit differently. Let's talk about the basic integrals. You've got to memorize these basic integrals just like you've got to memorize the derivatives. So make sure you memorize all of these basic integrals and their properties. And with these over here, you don't necessarily maybe need to know like the a squared part, but you know, you should know like you should know that like you should know what arcsine looks like, you know, and you should normally know that the derivative of arctangent is 1 over x squared plus 1. So maybe you just remember that, but then you don't remember all the u and a stuff. I understand that. So the u and a stuff is optional, but the core arctan, arcsine, arcsecant, those you should probably know. These are some optional integrals that might be useful. If you memorize them, great. If you don't, no big deal. And my computer just froze. Oh, I think we're back. Hopefully I didn't screw up my recording. It didn't look like it did. Let's talk about some important calculus theorems. I know you're probably like, where did MVT and IVT go? I wanted to do MVT, IVT, and FTC at the same time. So let's take a look at the intermediate value theorem. What are the conditions we need to know? We need to know that it's continuous on the closed interval from A to B, and that there's a number n that's somewhere in between f of a and f of b. We also have to make sure that the endpoints are not equal. And what this basically says is that there must be a value c such that f of c equals n, which really means that a continuous function must take on every single value between f of a and f of b. Makes complete sense. Check out my video on IVT if that's still confusing. Mean value theorem. Let's take a look at that. My computer froze again. Here we go. Conditions. It's got to be continuous on the closed interval, and it's got to be differentiable on the open interval. And basically what it's saying is that there exists some value c where the slope of the tangent line, that's what the derivative is equal to the slope of the secant line, or the average rate of change. Rolle's theorem is a special case of the mean value theorem. The conditions are, oops, I want to go back one. My computer keeps freezing. Oh my gosh, we'll just have to work around it. The conditions, it's continuous on the closed interval, differentiable on the open interval, and on top of that, the endpoints have to be equal. And it basically says that there exists some value of c such that f prime of c equals 0. And this is a mean value theorem add-on because, you know, obviously the slope of the secant line here, well, if the endpoints are equal, then the change in y is 0, so the average rate of change is 0. So that just means, that's why this is a special condition to the mean value theorem, because it still is the mean value theorem. You just know that the slope of the secant line is always going to be 0. Finally, the fundamental theorem of calculus. There's two fundamental theorem of calculuses. One is the really boring one, and we use this when we evaluate definite integrals, right? We take the definite integral and then we evaluate it at the larger limit and then subtract it from the value of the smaller limit. But this is the big one that I like to take away from the fundamental theorem of calculus, is that the derivative of an integral is just that function left over. The second fundamental theorem of calculus basically deals with the chain rule. So if you take the derivative, but then instead of having an x up in this upper limit, you've got some other function g of x, then it's f of g of x times g prime of x. That's how that works. The other thing I want to go over here is along the lines of MVT, but for integrals, so it's the average value of a function. So again, it's got to be continuous, and only the first derivative has to exist on the interval from a to b. And basically it just says there exists a value c such that f of c is 1 over b minus a times the integral from a to b of f of x dx, and then c would therefore be the average value of that function on the interval from a to b. Now that we've got those theorems out of the way, let's talk about some methods and types of integration. First off, use substitution. How use substitution works is you find the derivative of some function within the integral. So you'll have a function and its derivative all within the integral. You then change it to u and then take the integral with respect to u, and then back substitute u in at the very end. There's also long division. It helps you simplify the integral. You split it up into two integrals after you do the long division, and then it's usually the integral of the quotient and the integral of remainder, and the integral of the remainder, and then you simplify those. Completing the square, you use completing the square in the denominator. It simplifies, or it changes the antiderivative so that it meets either the antiderivative of arc sine or the antiderivative of arc tangent. And definite integrals you evaluate using the fundamental theorem of calculus, like we talked about earlier. Go over properties of integrals. There are some important properties of integrals that I would go over in an AP review book if you're still shaky on them. All right, let's talk about approximating area with Riemann sums. So this is the equation for a right Riemann sum. This is the equation for a left Riemann sum, and this is the equation for a trapezoidal sum where delta x is equal to b minus a over n. Make sure you memorize these. I am sure you're going to have to write one of these on the AP exam. So really, really, really know your right, left, and trapezoidal Riemann sums. All right, let's talk about area and length applications. So the area between two curves is given by the integral from a to b of f of x minus g of x. It's usually the integral from a to b of the upper function minus the lower function with respect to x. But be careful with the way some graphs look. It might be with respect to y, so just keep that in mind. Arc length, the length of a curve. BC will have to do this with parametric equations, but everyone's going to have to do this with any equation. So the way it works is the integral, the arc length is equal to the integral from a to b of the square root of 1 plus the derivative of the function squared with respect to x. No area between two curves and no arc length. Now let's talk about volume applications regarding integrals. First off, solids of revolution. There's two methods you gotta know for the AP exam. One of which is the disk method, which is you're summing up an infinite number of areas of circles. Now obviously you can take the constants out, so we just pulled the constant pi out. So really all it is pi times the integral from a to b of the radius function squared. You just take the area of that base, and usually that circle, the radius is usually that function. The washer method is the same thing, but it's dealing with solids of revolution that are hollow in the middle. So you just take the area of the outer circle and then subtract it from the area of the hollow part. Go over disk and washer method if that confuses you. And then finally, volumes of solids with known cross sections. If it's perpendicular, basically you're taking the integral of volume, or sorry, you're taking the integral of area to find volume. You're summing up an infinite number of areas to find the volume. Just keep in mind if you're doing it, keep in mind who's the boss. Is X the boss? And so you're doing it with respect to X, or is Y the boss? And you're doing it with respect to Y. Motion problems, you're just going to ignore this until I get to the end. I guess I clearly messed that one up. Let's talk about the motion elements. So there's position. This tells you the exact location of an object in relation to its starting point. Usually the starting point is 0. Velocity tells you how fast and in which direction an object is traveling. And acceleration tells you how much an object's speed changes in a given time variable. To go from one variable to the other, to go from position to velocity to acceleration, to go down this way, you take the derivative, and to go from acceleration back to position, you take the integral. That's a key thing you need to know. Derivative to go down to acceleration, and the antiderivative to go up to position. Other definitions you should know. You should know the average velocity. So this is just like the equation for the slope of a secant line. So you should know that the average of anything is just the slope of the secant line. You should know the difference between distance and displacement. Displacement is the integral of velocity. Distance is the integral of the absolute value of velocity. If you check out my video on motion problems, I explain why that's the case. And then finally, in order to find the position, again, we just talked about that displacement is the integral, and displacement is just the length of the path from where you were before at the initial time to where you are now at the final time. It might not always tell you the exact position in relation to its starting point. So to find the exact position, either if you're going the x direction or the y direction in relation to its starting point, you have to add on the initial condition of the exact position of the particle when time was equal to 0. So that's how you find position, and that's motion problems. I guarantee you guys, there's going to be at least one free response question on motion, so let's make sure we nail that question. Differential equations, let's talk about differential equations real quick. Remember the steps to do differential equations. You gotta separate the variables, you gotta integrate both sides, make sure you remember you got your plus c on one side, you don't have to do it on both sides. You solve for y, you substitute the initial condition back in, and again, steps 3 and 4 can be done either way. If it's easier to substitute the initial condition and then solve for y, go ahead. Do it whatever way is easier for you, and then finally, state your answer. I didn't mention slope fields in here because slope fields, in my opinion, are pretty easy, and they're pretty easy to catch up on and learn. So go to Khan Academy if you're a little bit confused on slope fields, or check out my channel for some videos on slope fields. So that's it. If you're an AP Calculus AB, you're done. That's everything you got to know for the AP Calculus AB exam. Now again, I just went through that super fast. Again, this was not meant to teach you the entire course over again. Rather, this is just meant for you guys to see what do you need to study and what do you not need to study. So if you're an AP Calculus AB, you can go ahead and close out of the video. You're done. But before you close out of the video, I want to say something to you guys. I put it on my slide at the very end, and I didn't mention it now, but since you guys are probably going to be leaving, I'll tell it to you right now. Do not let an AP test score define who you are as a person. You are amazing, you're smart, you're intelligent, and just because you maybe don't pass the AP exam or don't get the score you want, that doesn't mean you're worthless or anything like that. You are an exceptional individual, and you will do great things when you go on in life. And who needs math anyway, right? Alright, if you're an AP Calculus BC, don't close that window. We've got some more content that we got to rush through so that we can get all your content covered. So without further ado, I'll see you guys later, AB folks and BCers. Let's grind to the end. Alright, next up, there are a couple methods of integration that you guys have to do that AB didn't have to do. One of which is integration by parts. This is undoing the product rule. Make sure you know LIPET so that you don't have to go guess and check over and over again. And this is the formula for integration by parts. So the integral of u dv is equal to u times v minus the integral of v du. So make sure you find u, v, du, and dv when you do integration by parts. Integration by partial fractions, what you're going to do is you're going to factor out the denominator and then split up that fraction into the sum of multiple fractions and then solve for the numerators using a system of equations. Then that'll allow you to break up the integral into multiple smaller integrals and allow you to evaluate those smaller integrals really easily. I just gave you a process. I didn't really tell you how to do integration by parts and integration by partial fractions, so make sure you review that if that's still confusing. Improper integrals, that's how you guys can do improper integrals. If you got an infinity or negative infinity, you just take the limit as t approaches negative infinity or positive infinity and replace that infinity with a t. If you've got a function that has a discontinuity at either endpoint, at either limit of integration, you just take the limit as it either approaches the left, or sorry, as it approaches the positive end, if it's the lower limit, or the negative end if it approaches the upper limit. That's how you can solve improper integrals. You guys are gonna have to know these when it comes to series. This is a big deal when it comes to series. That's their big application, which we'll get to series in a minute. But first, we gotta talk about Euler's method and logarithmic equations. So Euler's method, the way it works is if you want to, you got a differential function with respect to x and y, and that solution passes through some initial condition x sub 0 and y sub 0. You can basically find that new value of x or that new value of y, and these are the equations to do it. Now, in past AP exams, you would be allowed to use a table to find this, but unfortunately, you can't use a table anymore. AP claims that that's not enough information. And so if you use these equations, you can use a table to help you structure your answer, but on a free response question, if you use these equations on the AP exam, these are what get you full points. The new position, or we were talking about motion, so I said position. The new x value will be the old x value plus the delta x is the step, right? So the old x value plus whatever step size you're doing. And the new y value will be the old y value plus the derivative of y with respect to x evaluated at the old x and y values multiplied by the step. Make sure you know how to do Euler's method without using a table. And then finally, logistic curves. This is what a logistic curve looks like. Note that L is the carrying capacity and the maximum growth rate occurs when P is equal to 1/2 of L. And these are different forms for the differential equations of the logistic curves. All right, let's talk about parametric equations. So the slope of a parametric equation, when you're given a parametric equation, you're given x of t and y of t. The derivative of y with respect to x is simply, you're just simply dividing the derivatives. So you take the derivative of y with respect to t, and then divide it by the derivative of x with respect to t. Super, super simple. Arc length, though, we should talk about arc length real quick, is the integral from a to b of the square root of the derivative of x, with respect to t squared, plus the derivative of y with respect to t squared. You gotta know that, and you've also gotta know the AB one. You gotta know both. I mean, my little tip for you guys is I would make sure you know both, but I feel like that AP is probably gonna ask you to use this arc length more so than they're gonna ask you to use the AB arc length. So if you know this one, but you don't know the other one, I don't think it'll be the end of the world. All right, let's talk about some polar equations real quick. The slope, just like parametric equations, you can simply divide dy d theta and dx d theta to find dy dx. But remember that the derivative, it's really just finding the derivative with respect to theta of whatever the radius function is times the sine, or whatever the radius function is times cosine, with the way trig works out. For finding the area of the polar curves, the area between two curves is the integral from theta 1 to theta 2, where theta 1 and theta 2 are the quote-unquote first two times that the radius is equal to 0, and it's just the radius squared. Pretty easy to find the area inside the leaf. And then arc length for a polar graph is the integral from the first angle to the second angle of the square root of the radius function squared plus the derivative of the radius function squared. Know those three ideas for polar equations. And then finally, vector-valued functions. I thought I made something so that, okay, never mind. It's okay, just pretend that that's not there for now. But that's an example of a vector-valued equation. Now remember, a vector has two components, an x and y component, and just to find the derivative of the vector, simply take the derivative of each of the components. So here's an example vector, the derivative of that, oh, what the heck? Oh, it's not there. Okay, let me just write it up real quick. So if you're given a vector-valued function, its derivative, you just take the derivative of this x, and you take the derivative of this y, and then you just keep those in the same components. It's just the derivative of each of the components to find the derivative of the vector as a whole. Pretty simple. Let's go back to motion and add in more motion definitions on top of the ones you know from AB. So the AB ones you've got to know as well as these. First up is speed. Speed is the magnitude of velocity, and the magnitude of velocity is the square root of dx dt squared plus dy dt squared, or x prime squared plus y prime squared. You should also know that you should also know how to find distance traveled. We talked about with AB that distance is the integral of the absolute value of velocity, and the way you can find that, it's the integral from the initial time to the final time. Those are the limits of integration, times the square root of the, remember, this is just like the arc length. It's just an arc length, right? The distance traveled is simply just the way that it just traveled along the arc. So it's the square root of dx dt squared plus dy dt squared. What are some other ones? Oh, finding position. A lot of kids only find the position for the x and the position of y. You've got to solve. I showed both of these. In the AB one, but AB only does one dimension, so they only need one or the other. BC, if you're asked to find position on the AP exam, you've got to find both. You have to use both integrals. So make sure you use both integrals and both initial conditions to be able to find the position. Velocity vector, that's what the velocity vector looks like, and obviously the acceleration vector would be the second derivative. Pretty easy stuff. Sorry, my throat was getting dry. I needed some water before we moved on. Let's go ahead and move on. We need to move on. Here we go. All right. Here are some common, we're going to switch over to series. It's our last big topic, and then we're done. So here you go. Here are some common series. The series of 1 over n always diverges. -1 to the n over n always converges. This is a geometric series. It always converges. And the sum of that series will be a over 1 minus r. But it will only converge if the absolute value of r is less than 1. Actually, it's not a geometric series. I lied to you. But it's a common series. That's what the sum would be. Actually, in fact, it looks the same down here. I think these are, I was right. These are both geometric series. Don't even listen to me. These are both geometric series. But now we can also see that it diverges if the absolute value of r is greater than or equal to 1. Know these common series. If you can just know these off the top of your head, it makes proving series convergent really easy, as long as you know these three things. Let's talk about some of the convergence tests. You got to know all these convergence tests, so I'm not going to go over them a ton. I'm going to highlight the P series. Know that it's convergent if P is greater than 1, divergent if P is less than or equal to 1. When you do the comparison test, make sure you're comparing a P series or a geometric series. Divergence tests, just take the limit of the series, and if it's not equal to 0, it's divergent. Pretty simple. Alternating series is the same thing, except for it, A, involves an alternating series, and B, both of these conditions have to be met, that the second term, that this function has to be continuously decreasing. Integral test, again, I told you improper integrals were going to come back, so make sure you review the integral test. And for the direct comparison test, make sure that you are actually comparing, when you're comparing it, compare it to a P series or a geometric series. The ratio test, I really want to go over the ratio test and the interval of convergence. Go over the interval of convergence on your own if that's still confusing to you. The interval of convergence is pretty easy to find. Consider that you know when it'll converge and diverge based on the ratio test. It will converge if the limit ratio test converges if the limit as n approaches infinity of the next term divided by the current term is less than 1. It diverges if the next term divided by the current term is greater than 1, and if it equals 1, that sucks. You know absolutely nothing, and you have to start completely from scratch. So, good luck, and the ratio test, I'm sure you're going to get a ton of questions on the ratio test at the AP exam. So if you're cramming, and there's convergence test that you got to know the ratio test. I'm sure that will be like a really big one on the AP exam. These are some other useful convergence tests. I don't really know them. I'm probably not going to use them, but there's the root test and there's the limit comparison test. Feel free to look at those if you need them. Optional, probably not going to be used a ton. But yeah, you could definitely use them as long as the series are both positive and you get some, and the limit of the quotient of the both of them is some constant that's greater than 0. It's going to converge. Same thing. How is this different? Oh, I see. So it'll converge as long as you know. So you have to know if one of the series converges or diverges. So if you know that B converges and this is true, then A also has to converge. And if you know that B diverges and this is true, then A also has to diverge. So yeah, optional. Don't have to know them, but it might help you. Let's move on. I clicked move on. Did I? I thought I did. Oh my gosh. It's not going forward. I think it's froze. Yep, it's... Oh, no, it's not. All right, here we go. Taylor and Maclaurin series. Let's take a look at this. All right, here we go. Taylor series. Function f, it's got to be smooth at x equals a. You can approximate its value by using an nth degree polynomial where each term is going to be equal to whatever derivative it is. So first, second, third, fourth, fifth at that certain point a, divided by the factorial of whatever derivative you took. So if you took the fifth derivative, it's divided by 5 factorial, and don't forget to multiply by x minus whatever you're centering at, raised to the nth power. Taylor series, make sure you know that. I'm sure you're going to get a free response question on that. Maclaurin series or Taylor series about x equals 0. Memorize these 5 and know how to manipulate these 5, because you're going to see these 5 all the time on the AP exam, and they're going to manipulate them to be different forms. So make sure you know how to manipulate a Maclaurin series to be what you want it to be based on these 5 basic forms. Let's talk about, again, it didn't... I hate this. It didn't save my animation, but, you know, it's fine. We can work with it. How much time we got left? Oh, we're doing perfect on time. All right, here we go. Error and remainder. I guess we're going to talk about... I think this is Lagrange error bounds. This is more on the remainder. So you've got some polynomial function of some nth degree. It's an nth degree Taylor polynomial about c. Then the actual function minus the Taylor polynomial is going to be less than or equal to this business. This is great to evaluate what the error is. Again, this right here, this is the error. And so you can evaluate the error by using this nifty equation. And then finally, the alternating series error bound, making sure that you know that the sum of the actual series minus the partial sum has to be less than, again, this is also error, so the error is the sum of the actual sum of the series minus the whatever partial sum of the series, that's going to be less than or equal to whatever that term is. So if we took the 6th partial sum, then this error must be less than or equal to the 7th term, if that makes sense. All right, that's it. BCers, you're also good to go. So ABers and BCers, that is everything you need to know for the AP exam. Again, BCers, I went really, really fast, so make sure that you go and review what you don't know and that kind of thing. If you guys like my video and you found this helpful, comment, like, subscribe for when more videos come out. It really helps the channel out and gets this content in the hands of people who would really enjoy more content. Again, BCers, you guys are absolutely amazing, and do not let an AP score define who you are. You are brilliant, and you're going to go on and do incredible things in life. And with that being said, I hope you guys get that 5 or whatever grade you want on the AP Calculus exam. Thank you guys so much for sticking around for this giant video that's going to be about 40 minutes long. I appreciate the support that you guys are giving me. Thank you again so much for watching, and I'll see you guys after the AP exam. Hey!